Hi, my name is David Valdepeñas Nieva, and I want to show you the project I've made with the GeoGebra program. I've called it the Traveler Pendulum with Electric Field, and it is based on the periodic movements, which are those that not only travels at a closed path, but also pass in equal time intervals through any of the points with the same speed. In this game, we're going to combine the periodic movements of the pendulum and the electric field that is produced by the charge in the ball. Well, the point of this game is to find out in which place and under what conditions the resultant electric field will be the maximum. Well, I'll show you how to do it. You have to move the bars with the variables so as to change the result, and you can change the 4 variables, but you can also change the place where the pendulum is so as to change its gravity, and the result will also vary. There is only one possible answer, and when you find it, the electric field will change from green to yellow. So will you be able to find it? Well, if you need some help, here you have a button where you can press and some formulas will appear. Here you can guess which variables you have to vary to make the electric field bigger. Also, if you still cannot find the answer, by clicking this button you will find it. Another clue is that by pressing the start button you can see the speed of the pendulum, and if you change the place you can see that, for example, in Jupiter the pendulum goes faster than in the Moon, so the gravity is higher in Jupiter or in Saturn than in the Moon. Now I'm going to show you what's behind all this game. Here I have the Excel I made before the GeoGebra, and in here I made a study of all the variables before starting the GeoGebra, so as to know which variables I have to change to make the electric field bigger. The first variable I studied was the angle, and I saw that even if I changed the angle, the electric field stays the same. This can be seen in the GeoGebra, as if I change the angle, the electric field stays the same. On the other hand, if you vary the mass, the electric field changes. As we can see in the graph, as you increase the mass, the electric field also increases. This can be seen in the GeoGebra, as if I change the mass, the electric field varies, and if I make it bigger, the electric field will have higher values. The next variable to study was the charge, and as we can see in the graph, when the charge approximates to 0, the electric field gets bigger. Look, as we approximate to the 0 in the charge, the electric field gets bigger, but if you make a bigger charge, the electric field gets smaller. Then we have the length, that it is indirectly proportional to the electric field. So when you have a shorter strand in the pendulum, the electric field is much bigger than if you have a larger one. This is more visible in the GeoGebra, as we can see how the pendulum's strand gets smaller or larger, and how it varies the electric field. The last variable to study was the period, and we can see that when a pendulum's period is smaller, the electric field gets very big negative values. When it is bigger, the electric field is positive. Now let's see it in the GeoGebra. As I make the period smaller, the electric field takes very big negative values. Well, to finish, I am going to show you the answer. Well, as you can see, we have to put the pendulum in the moon. Then the mass of the pendulum has to be 0.8. The charge minus 1, the length 4 meters, and the period 0.5. And that's all, and I hope you enjoyed it.